Hello? All right, so that's what we're looking at as far as the common logarithm is concerned again. Now, let's think about phase shifts here. What if I have y equals to the log base, and again, I know this isn't technically correct. Whether I have log base 10 or log base 8, as long as that base is greater than 1, they're going to take on that same shape. Now, I mean, there will be a little bit of differences in the steepness and so forth, but it'll essentially take on that same shape. Let's think about what the graph of this would be. Well, in the past, when we had a -1 grouped with the x term, what did that do to the graph of it? Shifted to the right, actually. If it was outside of it, that's when it shifted it down. So this would shift to the right one. So the graph of this, here's 1, it would actually do that. And its domain would be 1 to infinity.
So do you kind of ignore the 8? When graphing?
Again, I hate, yeah, when graphing, it's going to take on that shape. But if you want to know like specific points in it, you would think, okay, well, let's say that this number right here is 64. Well, 8 to what power gives me 64? 2. 8 to the second power gives me 64. So I would be way over here at 64 and just barely be up 2. Whereas with the log base 10, I'd be over at 100 before I got up to 2. But you see, both of them, you have to go a long way out just to get up to 2. So for that reason they generally take on the same shape, but we're not going to take our time and plot out to 64 or 100 and then finally go up 2. Desmos will do it for us. But outside of that.
The range would still be all numbers, right?
Yeah, the range, great point. The range is still all real numbers because it still goes down forever and it will eventually go up forever. So it doesn't change the range.
Is that how it is with all of logarithms?
Yeah. I had to think. That all is a scary word. So, but if it's 1/2, I mean, still, yeah.
It's still gonna go both ways.
Yeah. All right, so now, they really won't, for the reason that you just stated earlier, you said something about shifting down 1. They really don't do that much on logarithmic graphs because you can't, it's harder to see that a graph shifted down 1. So yeah, x minus 1 is going to shift down 1, but there's such a, I mean, you're talking about, the graph would look something like that as opposed to, it's just not, there's not going to be a huge difference in the way the graphs look. It's easier to see the shift to the right or left. So, without graphing it, what is the domain? And it doesn't affect the range overall. It won't affect the range. So what is the domain? That's horrible. Of y equals the log. Y'all don't like 7s. 7s are horrible numbers. Ooh, let's make it 7/5. Log base 7/5 of x plus 2.
-2 infinity.
Very good. 7/5 didn't have anything to do with it, did it? bless you, x plus 2 has to be greater than 0, so x has to be greater than -2. So we would say from -2 to infinity. And we'd be there. Any question about that? All right. So that's a good lesson for today. Go ahead and be working on it. We're gonna go a little bit deeper into properties of logarithms next time. We're gonna learn what it means to add logs together, subtract logs, multiply logs, divide logs, things like that. So anyway. What now? 4.2, yes.